development. Marco will touch on both the container and virtualization toolkit today, and he'll explain to you what that roadmap looks like and the purpose of the migration toolkit for virtualization as well. And finally, joining us, Ashok from IBM Research is going to present on Move to Cube. This is actually a pretty exciting new project that was open sourced by the IBM Research team. As IBM Research was supporting a customer moving from Docker Swarm to Kubernetes, they developed this tool, which has since grown to be able to support migrations from Cloud Foundry and other platforms to Kubernetes as well. So Ashok will do that as well. So each of these areas will have kind of a dive into each of these toolkits and technologies, and then give a quick demo of each of them is the idea. So with that, let me hand it over to Miguel, and he can take you through the migration toolkit for applications. Miguel, do you want to share your screen and take it from here?
Sure. Thank you very much, James. So, hello, my name is Miguel Perez Colino, and I'm the product manager for Migration Toolkit for Applications. So probably you know Migration Toolkit for Applications by its previous name, which was Application Migration Toolkit, and it's not a tongue twister. And also by the upstream project. I mean, it's fully open source and it's available, which is WindUp. So what does this do? It can help you review Java applications, whether in its source code or binary form. We can review them and check for compliance against rules. What kind of rules do we have? Well, we have rules for checking Java EE kind of classes to see if we are using this kind of classes, so your application is more portable, so you can bring it from one application platform to another. We check for JDK, so if you're using Oracle JDK and any of the proprietary classes that come with it, we can review them and let you know, hey, we found this. We check also for things that are related to Windows. So if you're using, let's say, a path that is Windows specific, we'll let you know so you can move it to Linux. So, and we have also specific rules to containers following the 12-factor application guides. So we have this kind of rules that would help you, as I say, review your code, review your application, and be able to work on it to be able to improve it. And also, you can create your own custom rules, so you do not work twice. So sometimes you have your own framework where you're working, and there's all this development team that is using the same framework, and you have find an issue that is causing the application not to be able to be moved to, let's say, Linux or any application platform that is JEE compliant, or containers, or in this case, OpenShift. So you could write your own rules and point the rules to your own recipes. So whenever a developer finds this issue, he or she could make the modifications much faster, reducing the time to bring to onboard applications on your cloud platform. How do we provide this? Well, there are four deliverables that we provide. One of them is the web console, which I'm going to show you in a minute. And it is the easiest way to get started. You just download a zip file, unpack it, and run a script file to start it. And all you need in your laptop is to have Java and 8 GB of RAM. So as long as you have that, you can run it, you can go through it, you can see it, and you can use it. We have also a CLI to be able to embed it in pipelines or to use it in an automated fashion. So whenever you have to, say, do analysis in a very repeated way, or you have to analyze like a huge amount of applications, you could use the CLI to do so. We have also a Maven plugin, just in case you want to embed the analysis in the builds, and an IDE plugins for code-ready workspaces, which is our version of Eclipse that runs on OpenShift. Also Eclipse, and Code-Ready Studio, which is a created version of Eclipse that Red Hat provides, like Red Hat's build of Eclipse, and of course Visual Studio Code. So you can get this plugin, install it on your IDE, and get started analyzing the applications to see how they work. So now let me show you. This is Migration Toolkit for Applications. It's running on my laptop. And right now we have a project. We could start a new project. So this would be like a test project. Okay, let me log in again. Okay, so this is the test project. So I can start migration project number 2. and then say, okay, let's analyze some applications. I click next, and I could add some applications. So just in case you need some applications to start with, you can have you can go to the wind up project and download it from there. So we have rule sets, you have sample applications, and in this repository you can download here from the sample binaries, some binaries to just test your migration toolkit for applications. So I choose those files. I go home, code, app migration, sample applications. This is the repository I just pointed out. I go to sample binaries and I choose these 5 binaries, click open. They upload. I mean, they're on my laptop, so it's fast. Next, and then you can configure, okay, let's check for rules that are intended to be for JBoss EAP. These are JEE rules, you know, so your applications is JEE compliant. This is containerization rules. These are rules for Linux. These are rules for OpenJDK. And of course, we have more advanced options that you could add here. And among them, we have right now, we have added some camel rules that could help you bring from camel 2 to camel 3. Camel 3 is a lot more container oriented, has many Kubernetes integration, is very interesting. So if you're using Apache Camel 2 and you want to move to Apache Camel 3, you can also use the migration toolkit for applications. So we have right now this analysis, and I can click on save and run, and then the analysis will be queued and then started. So let me do like in the cooking shows, and I'll go to another project that has already finished the analysis, so we don't have to wait. So this is what happens when you finish analyzing it. You could go to the analysis part and check. This is the report for the set of applications that I have analyzed. I can see the 5 applications that I added. I could have added 20 or 50 or more. And then you see that this application is already ready for JBoss EAP. We have JBoss Web Server that is like Red Hat's build of Tomcat that is fully supported. So you could check here that this component is not going to be supported if you run it on JBoss Web Server, but everything will be supported for JBoss EAP. Same thing for all the applications that I have analyzed, so I can check that which ones of them are going to be supported. Then to the important part, the issues, you know. We found 35 instances of this issue. So we're using a WebLogic proprietary logger, and it has found it in these cases. So in here, we have links to the JDK login documentation. So you could use JDK login or JBoss login. So you will be able to get into the applications and change the logger to make it fully compliant with JEE, and then be able to move your application. So you have these migration mandatory rules. So these are the rules that we have found that you will need to change. And I'm showing more examples. Then we have some optional rules, some potential rules, then some cloud mandatory rules. So in here, for example, we are using some embedded cache library. We'll need to change it to make it more suitable for containers, and then some informational rules. So same thing, you could check for each application. There's a report, and you could go to each one of those applications, and it will give you some guidance on the story points, the effort that it will take to migrate this application, for example. Same thing with the issues, but just for this application. So I could take a look at the application and be able to change it, some application details. So in this case, this is an easy one, 7 story points, because there are minor issues that we need to change. Of course, this is an application that is fully suitable for JBoss. But we could take a look at this other application. This is much more complex and has more incidents that we need to check. And we can check, as you see, that there are more items to be changed. There's 112 story points, and it will tell you which packages. We could check which technologies are being used in these applications. The dependencies graph to see if we are using any component that is used elsewhere. What was not reviewed because there were issues passing it, and the dependencies, enterprise Java beans, a lot of information, okay? So I think that with this, we can realize that we could get a very good overview on what would it take to analyze an application and be able to decompose it in a way in which we will be able to bring it to different technologies, and especially to containers and to OpenShift. And with that, I go over to my colleague and friend Marco Berube, who is going to talk about migration toolkit for containers.
Thank you, Miguel. Let me just share my screen. So next tool is the Migration Toolkit for Containers, or MTC for short. So MTC is available in OpenShift in the Operator Hub. We just released MTC 1.3 that is now available. The main use case of MTC right now, actually, MTC is used to migrate an application from one OpenShift cluster to another OpenShift cluster. We support migration from 3 to 4 as long as you're at least at 3.7. Or from 4 to 4. So it's possible as well to use the same tool for migrating applications between your OpenShift 4 clusters. But right now we're seeing a lot of demand from customers migrating applications from OpenShift 3 to OpenShift 4. So this on the right side here, I have the list of the things that were changed or added to the latest release of 1.3. So we actually rebranded the tool. So maybe you knew the tool before as a cluster application migration, or CAM, as we are rebranding everything under the Migration Toolkit name. So now the tool is named Migration Toolkit for Container, and it's available in Operator Hub under that name now. The second thing is we have added in the tool a more detailed view of what's getting migrated. So one of the feedback we got from customers is when you are migrating your application, sometimes it would be good to know from the tool itself exactly what is about to get migrated inside those namespace. So the tool migrates an application from a namespace point of view and all the resources that are actually attached to that namespace. And sometimes it might be difficult to understand exactly what are all the resources that are actually attached to this namespace. So now we provided information directly in the tool. So before you click the migrate button, you can review exactly what is going to be migrated and why it's fast or why it's slow, depending on the amount of resources that actually and the amount of data that is actually going to get copied during the migration process. The second thing is that we spend a lot of engineering effort on is to improve the debugging of directly from the tool itself. So we're trying to reduce the amount of time you would have to go command line to try to dig into the logs or figure out exactly what's happening behind the scenes. We're trying to make this as easy as possible from the tool itself, even if something goes wrong, that you can find the appropriate information directly in the tool. Or if for any reason you need to go dig behind the scene, then we're trying to as well provide you the right command or exactly where to go from the tool itself to provide you some guidance on how to go do some deeper analysis on what's happening behind the scene. As well as finally, we also have created a best practices guide that is available on GitHub. So, and this is still something that is work in progress. And this is mostly like outside of how to use the tool itself, which is properly documented on inside the OpenShift migration section. But best practices are more than the tool itself. Is what are the most common steps that that are usually followed to have successful migrations, right? Outside of just how to use the tool is how to make sure that that you're following the right steps to migrate your application at scale from one cluster to another. So I'm just gonna show you a demo of that tool now, and then we'll get to MTV next. And by the way, here I'm showing you the reason why you see Konveyor on the top right is this is a recording from the upstream community version. As everything we do at Red Hat, right? We work open source on the upstream first, and when everything has been fully merged and fully tested, then we release it as a version inside OpenShift, inside Operator Hub. And this tool is based on other community projects like Valero and Restic, which is all getting consolidated and tested upstream under the Konveyor GitHub repo, and then once everything is solid, then we release it. So as this tool is freshly released as 1.3, this is why I recorded the demo from the upstream version just a few days before the final release was out. But it's the exact same tool. It's just like this is the latest and greatest of the tool. So first you would configure your cluster, right? Your source and your destination cluster. Then you need a replication repository. So this object repository is to copy the data to and from while we're doing the migration. So I'll pause here. So when you're doing a migration, what's happening behind the scene is actually a backup and a restore of your application. So we back up all the data to this object repository, and then we restore it on your destination. Then you're ready to create your first migration plan. So here I'm calling it demo. I'm picking my source cluster and my destination cluster and my object repository that is going to be used during the migration. Then here I have the list of namespaces that I could migrate. Here I'm just going to pick one namespace, and I can see the amount of pods and PVs and services that are running in that namespace that are going to get migrated. Then I see all the volumes or the PVs, and I have different mechanism of copying those PVs over. I can either do a copy or a move. So a copy is when all the data is going to get copied using Restic, which is like a backup service that is doing a copy of all your data. Where a move is typically used when you can share the same storage backend. So NFS would be a good use case, where if you have the same NFS storage on both sides, then we can just unattach the PV on the source and reattach the PV on the destination. So it's faster, as we don't have to copy any data. We can just reattach the same PV. Next, on the next page, you have a couple of different options. So if you're doing copy here, you have the snapshot capabilities that can be used in the cloud if you're using a cloud storage. And you also have a verify icon that can do like a checksum at the end to make sure that everything has been fully migrated and nothing has changed data-wise. Then you have the migration hooks. So a migration hooks is a way to add automation during your migration, like during the execution of a migration plan. So you have pre or post migration hooks that are available. This can be as simple as uploading like an Ansible playbook that we can run before or after the migration, or you can customize your own image as well that you can make available from the registry, and then we can launch that image as a pod or as a service while you're doing the migration before or after the migration. So this way you can add any kind of automation, the default like migration flow, to increase the amount of things that could be automated during the migration process. Then finally here, now that I have my migration plan, I'm just going to execute that plan. So, and first I can, I can first review what is actually going to get migrated by looking at the namespace. This is the new functionality I was talking about. So here I can look at all the details of all the resources that are inside that namespace that are going to get migrated. That gives me a good indication of exactly what's going to happen during the migration process. And then I can either stage or migrate. So I'm going to pause it for a second. So here I have a couple of options. So when I do a stage, staging is actually copying as much of the data as possible from source to destination, but without flipping the switch at the end. So at the end, we're not shutting down the applications. We're not doing the final migration. So this is a way just to accelerate your migration later when you're going to do the final migration. So this is something that, as an example, could be done during business hour. You could stage your application so you are ready to do the final migration during a maintenance window that could happen overnight. So here I'm going to stage first. And then I could do the migrate. And then I would have access to the logs or the debugging information as well if the logs are not sufficient, if something goes wrong. So here I'm doing the first staging process, and this takes a few minutes. It will copy all the PVs, all the resources, all the definition of what's inside that namespace, and get this as ready as possible on the destination side. I'm going to fast forward that to accelerate this. And then once this is completed, this takes a few minutes. Obviously, like the amount of time it will take depends on the amount of data that needs to be staged and how fast is your network and your storage, like how much higher you have. This was typically so doing some performance testing at the beginning to understand like how fast you can copy data from one cluster to another will help you estimate like the amount of time it takes to do the final migration. And then once you have staged and everything has been successful, then during your maintenance window, I can do the final migration. And here I have an option as well that says don't halt transaction. So even during the final migration, if I would click migrate by default, then at the end of the migration process, the source side will get scaled down to 0. Actually, your application will get quiesced, and then we'll scale down the application to 0 before we actually launch the application on the destination side. If my application allows it because it's fully stateless, or if I'm doing testing, then I might want to keep my source side as well up and running, even during a final migration process. So here, as this is a lab environment, I'm going to click the don't halt transaction, which is going to skip that final step of shutting down my source cluster. So it's still going to do the final migration where I can flip my DNS or my load balancer to point to my destination, but I'm not going to shut down my source cluster as right now I'm doing this for testing purposes inside of a lab. So this option allows you to test a final migration without affecting what is actually running on your source cluster. That's pretty much it. So this will run again for a few minutes and until my migration is succeeded. And then after that, I would have access to all the debugging information. If something went wrong, then I could have access to all the backend information to troubleshoot the migration process if something wrong would happen. That's it for MTC. I'm going to go back to my slides. And I'm going to get to the Migration Toolkit for Virtualization. So Migration Toolkit for Virtualization, or MTV, actually is a tool that is also available for free inside Operator Hub, or will be available for free inside Operator Hub like MTC. And it's going to be available as a tech preview release in December 2020. So right now, this tool is not available yet. This is something we are currently finalizing, but we've spent a lot of engineering effort before on similar tooling, which was called IMS at the time. So IMS was used to migrate applications from, as an example, from VMware to either Rev or OpenStack. And now in this case, we're doing the exact same thing, but for OpenShift virtualization. And so all the tooling in the backend, like pretty much like the Linux-based tooling that is used to convert the disk and import the data from VMware as an example, is actually already pretty much built in. Now what we're actually finalizing is leveraging the OpenShift API to import the VMs inside OpenShift, as well as building a new UI experience that is available as an operator inside OpenShift. And the main use case is for this tool is for mass migration of VMs from VMware to OpenShift virtualization first, and then we'll also support in the future Rev and OpenStack as well as some new migration analytics capabilities. So we used to have migration analytics capabilities inside the cloud, where customers could download like information about their environment and upload this to the cloud to get better indication of if their VMs were compatible with the destination target. In this case here, now we will have migration analytics available on premise inside the tool itself that will help you analyze those VMs and let you know if those VMs are fully compatible or if there's known issues when migrating those VMs to OpenShift virtualization. Or sometimes they're not issues, they're just additional things that need to happen manually outside of the migration, the automated migration flow, or as well as some things that need to be architected differently, as obviously the OpenShift technology is a little bit different sometimes on how you would do all kinds of features from the legacy more hypervisor. That tool that is adding a way quicker to access that data before launching your migration. We still have this cloud-based migration planner that's going to be available in the cloud as well for even further deeper analysis of your overall VM footprint to help you understand, for example, like how many of those VMs would be compatible or actually good candidates to migrate to OpenShift virtualization. Then, yeah, and again, all that's going to be available as tech preview in December, and we're hoping to have this fully GA in April 2021. Then I'll pass this to the Move to Cube team. Oops, sorry, guys.
Thanks, Marco. So let me quickly share my screen. Okay, Amit, are you there?
Yeah, hey Ashok.
Okay. Yeah, can you quickly talk about the slides and we can then go with that?
Yeah, a quick one. Hi everyone. This is Amit Singhi from IBM Research. Really glad to be talking to the community here. So Move to Cube is a recently open source project James mentioned as part of the overall Konveyor initiative. It really started off with requirements that we saw within IBM with our large clients in multiple industries. One particular client in the insurance sector was looking to move one of their applications over from Docker Swarm over to OpenShift. And turned out that that was a big cost and time barrier for them because you need deep expertise in both the source platform of Docker Swarm and in OpenShift as the target, and then in the application itself. So that's where Move to Cube was born, to automate that journey by auto-discovering the deployment specification of the application in the source environment, translating it over to a Kubernetes model, and then incorporating the features of Kubernetes that are needed to make it run on the target environment, and then generating the deployable artifacts like Kubernetes YAMLs and help charts. Since then, the team has done a lot of work to expand it to other sources, Cloud Foundry being another big interesting one, as a lot of clients out there and businesses are looking to move from Cloud Foundry to more scalable Kubernetes architecture. So that's where we are, and I'll hand it over to Ashok to take you through some of the detail on it.
Thank you. So MotoCube, as Amit explained, helps you move towards Kubernetes platforms, any flavor of Kubernetes, like the normal Kubernetes or OpenShift or any other flavor. MotoCube tries to translate from many of the source platforms like Docker Swarm or Cloud Foundry and any of the language stacks or Kubernetes, in future even ECS and ACS, in a uniform way to Kubernetes. So it does the process of discovering all the artifacts and then translating them and then optimizing the configurations for best deployment into Kubernetes and architecting them in such a way that it has good data operation characteristics and stuff like that. It can do the same for all the source platforms while moving towards Kubernetes. And the way how it does, we will just look at it in a minute in a quick demo. At the end of all these translations, what we get is the artifacts which we can deploy to Kubernetes or OpenShift. And in cases where the source platform is a non-containerized platform, it can also containerize your application. And MotoCube supports 3 kinds of containerization techniques. One is Docker. Sorry, was there a question? Oh. Okay, so MotoCube supports 3 kinds of containerization techniques. One is a Docker file, another is a cloud native build pack, and then a source to image. And by default, it supports most of the language platforms, but if there is a unique language platform or you have a unique requirement of using a particular base image, MotoCube gives you a completely extensible framework with which you can add your own Docker file base images and stuff without having to edit a single line of MotoCube code. In addition to that, MotoCube can also create Helm charts for you and stubs for operator. If you choose to have it, you can also create Knative artifacts for your application. We are also enhancing MotoCube to create Tecton pipelines for you, so that the moment all the translation is done, you have a CI/CD pipeline also up and running, and you are ready to go. In summary, MotoCube tries to do the discovery and then containerization, do the translation, and optimize the artifacts, and then customize it for a very specific cluster that you are going to target. With that summary, let me take you through a quick demo of MotoCube, where what we are going to look at is the different stacks that we are seeing here. We are going to see a flavor of each one of these applications, and then going to use the same process to translate all of them towards Kubernetes artifacts. MotoCube is an open source project. It is open source in this Konveyor community. You can go to github.com konveyor/MotoCube to access the source code. And the demo that you're going to see is in the MotoCube hyphens demo, the unified flow one, which is going to look at all the source artifacts and do a one-step translation to Kubernetes. Okay, so MotoCube uses a 3-stage process to encapsulate all these complex things. The 3 stages that we will be looking at are collect, and then there is a plan phase, and then there is a translate phase. In the collect phase, MotoCube can collect the artifacts from the runtime environments. Let's say you have a Kubernetes cluster that you want to deploy to. MotoCube collect will get information from the runtime instances that is in your terminal context. And if you want to have a source platform like Cloud Foundry and you have access to a Cloud Foundry instance, all you need to do is to do your MotoCube and then collect command. And as soon as it finishes, what it does is it creates a m2k_collect folder, the sample of which is in the left-hand side. You can see I've done a tree of the folder that I'm looking at. So it has two files in the m2k_collect. One is a CF apps, and there is a cluster. The cluster.yaml is essentially a description of your actual running cluster. It has information like the storage classes and all the kinds and the versions that are supported by the cluster. This helps us know characteristics about the cluster without getting into specifics like which Kubernetes version is it or which OpenShift version is it. It is defined in terms of the actual resources the cluster supports. And then the MotoQ collect, when it has run against a Cloud Foundry instance, will create a YAML file with all the running apps that it could find in that running instance of Cloud Foundry, which might have information like the environment variables, what is the name of it, and stuff. So what we are going to do is, once the collect phase is done, you have this collect folder, and you just put that folder along with every other source code that you want to translate. Let's look at the different artifacts that are here that we are going to translate. In this case, the base folder is a CF Node.js folder, which has a Node.js application with a manifest.yaml for deploying to Cloud Foundry. So it's a Cloud Foundry Node.js application. And then there's a Docker Compose file. If you look into the contents of it, which is all available in the GitHub repository, you will find 3 services which needs to be translated. So it is a containerized application. And the third one is a Java Gradle one. It has the source code and the Gradle related files. And then there are also some Kubernetes YAMLs for a particular Node.js application, a deployment, ingress, and a service. So what we are all going to do is to just take this base folder, which is the sample/unified flow, and going to give it to MotoCube in the second phase of MotoCube, which we described as plan. So all it does is you need to give MotoCube space plan space samples/unified folder, and it does the job. So what it does is it goes to each and every file in each and every folder that it can find, tries to figure out whether there is a Docker file, a Compose file, Cloud Foundry manifest, Knative files, Cube files, everything, and then any metadata that it can use. It's going through each and every file to understand them and correlate among each other. Once it does the correlation, it creates a plan for you, and a plan looks like this. It's a YAML file, which has a list of all the artifacts it has found. It says, I found your 3 Kubernetes YAMLs, and it says, okay, I have found multiple services, which each one of different types. For example, there's an API, which was found in the Docker Compose file over here, and I can convert from Compose to Kubernetes using this image, and I will reuse the Docker image, so you need not update your containerization pipeline, but you have to change your CI/CD pipeline to deploy to your Kubernetes cluster. And then it says, okay, I found a Java-based Java Gradle application, and I can either create a Docker file for you, or I can create a cloud native build pack for based containerization technique for you. Also for the Cloud Foundry app, it says that, I found a Cloud Foundry application. I found some source artifacts like manifest YAML. I also found some runtime metadata. I can combine all of that for you and also containerize the application and have it containerized to Kubernetes. Similarly, it is proposing multiple containerization techniques for you for the same Node.js Cloud Foundry application. Similarly, for the Node.js Kubernetes, it is just also listing that and the other 2 services that it found in Docker Compose. And then it's saying that I found a cluster information. Do you want to target that particular cluster? By default, it understands Kubernetes and OpenShift, but any flavor of cluster, as long as you've done a collect, it can just target that. So you see that it is automatically targeting that, and it's saying that what is the artifact types you have to support. In this case, by default, it's YAML. So let's take this plan and give it to MotoCube's next phase, which is called translate, and let it run. So since the m2k.plan file is in the same folder, it's going to take that and execute the translation. So here it interacts with me to understand the missing information. So first it's asking, okay, I found all the services. Do you want to actually translate all the services? And then it's saying, okay, I know these kind of containerization techniques. Do you want to support all of them or only a selected few? And then for each of the services, it's asking what kind of containerization techniques I need to use based on the types it knows, right? And then it's saying whether to create a Helm chart or YAML or like that. And then it's saying which cluster I need to support, and you can choose your custom cluster. In this case, there's a cluster.yaml that I'm going to choose, or I can also choose the default OpenShift. And then it's asking what are the services which needs to be exposed externally. So it's giving the list of all of them. And I'm just going to give next for the next few questions and see what it does. So now it has created a folder called My Project for you. Let's see what is that. So this is the folder it has created for us. What it has is it has some scripts in the base level which helps you orchestrate it. It allows you to build the images and then push the images and install it with Helm or the normal YAMLs. First, it has created containerization scripts. For Cloud Native Build Pack, it has created a script which can create container using Cloud Native Build Pack. For Dockerfile, it has created a Dockerfile and a script to build it. Similarly, if you have chosen an application which has S2I, it would have done that too. In addition to that, it has created a sample Docker Compose file so that you can run the container images that you are creating locally to test locally. And then there is a cache on all the answers that you are given, so that you can put it as part of a pipeline, and you need not, it will not interact with you. It will choose the default answers. Also, it has created a Helm chart for you. And if you notice, even though all the source artifacts were deployment, ingress, and service, it was able to convert all of them to the OpenShift cluster we were targeting. So it has created deployment configs for you, image streams for you, and route depending on what you want to deploy. And it has also parameterized it and created a values.yaml, and it has created the operator stuff for you. And it has created all the other scripts that are required to install it. So this is all a manual command line process. You can do it one application at a time or all of them together. MotoCube supports all this. In addition to the command line, we also support a UI. So the UI is right here. It has this assets plan and target artifacts tab. Whatever you saw right now in the command line tool, you can emulate all of them in the UI and get it going in a second. And the only thing you just need to do is to Docker Compose up of the Docker Compose file, and you have this UI up and running. So that's a very brief demo of how you take the different artifacts from the various source platforms and translate it to Kubernetes artifacts that you can then deploy to your cluster. With that, I'd like to hand it over back to James for talking about the Konveyor community. Thanks, James.
Thanks, Ashok and Amit, and Marco and Miguel as well. So I'll try and keep it brief and bring us home. Hopefully you can see my shared screen now. Yeah, so as Ashok mentioned, and one of the things that we're working on is, as Marco and Miguel had mentioned as well, we have an upstream first development process at Red Hat. And so one of the things that we've recognized is that there is a large and growing community and interest in tools and best practices around how to modernize applications, whether it's breaking down monoliths, adopting containers, how to take your existing virtual machines and move them forward into a Kubernetes orchestrated manner. We certainly see a lot more interest and need for this. And so we want to do this the open source way. And so what we're working on today is something called the Konveyor community. Ashok had mentioned how the IBM research team had open sourced Move to Cube into that community. We're at the point where we have a bunch of source code and projects that are in there. The source code for all the projects that you saw today, except for Migration Toolkit for Applications, is currently in this Konveyor community. And our goal is to continue to catalyze this community and bring more source code to here, but then also even bring more of the practitioners around people who are modernizing these applications and working in these areas together over time, so that we can create a really a vibrant and diverse community of people who can share best practices and inform the tooling that you just saw to help improve it and make all the practitioners more efficient and more effective at modernizing these applications faster. So we'd invite you to join us on the Konveyor Slack channel. So if you're on the Kubernetes Slack, I believe it's actually I think it's slack.kubernetes.io, not kubernetes.slack.io. But if you go to slack.kubernetes.io and join the Konveyor channel, we'd be happy to continue the conversation there, whether you were interested in learning more about the community, learning more about the tooling, or getting more involved, or have comments or questions. We'd welcome them. So with that, I would like to thank the presenters and turn it back over to Diane, and she can close us out.
All right. Well, I'm really amazed at how much that's actually been done, and I haven't seen any questions from the audience yet. So I think there's been this whole conversation with end users about helping them do migration from wherever they are, whether it's on an earlier version of OpenShift 3 to 4 and over the past couple of years. And it's pretty amazing to see how much work everybody's been doing to make that happen, and to really facilitate people being able to deploy wherever they want, and move there successfully. So I really I'm a little overwhelmed at how much you guys have done in the past year and a half, and I'm thrilled to see the work that IBM has been doing in the research group from Amit and Ashok. So this is really, kudos to all of you for making this happen, and we're really grateful. And definitely, if you're listening to this anywhere and you have questions, check out the Konveyor GitHub repo. Join us on the Kubernetes Slack and find us there, and we'll answer your questions. If there's a platform we haven't touched on yet, I think I saw an Amazon EKS lift and shift to OpenShift, sort of grayed out, that maybe that's in the future roadmap. James, is there anything you could talk to about that?
Yeah, so as far as kind of the future roadmap, so on the migration toolkit for container side, and I'll let Marco, Miguel, and Ashok all keep me honest here, is really the migration toolkit for containers. We're working on really the robustness of the tool itself to make sure that it's entirely bulletproof when you're moving applications from one Kubernetes cluster to another. There's kind of a lot of work we're doing on there from a performance and logging and troubleshooting standpoint, just to make sure that it's a really great user experience before we go adding a whole bunch of features to it as well. So that's, I think, the current kind of the current area there. On the migration on migration toolkit for applications, there's a lot of focus right now on kind of Spring Boot to Quarkus and helping with those specific rules, as we've seen quite a big demand there, as well as building out something called Pathfinder, which was developed in our services team, and integrating that with the migration toolkit for applications. So it'll allow for you to understand the really get some advice around whether or not an application is suitable for containerization based on a series of questions that you would answer. And then on the migration toolkit for virtualization, right there, we're just trying to get that out with VMware support. In the future, we're going to want to add Rev support to help our existing Rev customers move over to OpenShift virtualization as well. And Ashok, I can't speak for the move to Cube roadmap. That's all upstream right now. So do you have any thoughts on that?
As far as MotoCube is concerned, we are trying to build it as native to Kubernetes as possible, so that we can scale it across any flavor of Kubernetes. And as we open sourced, we have seen a lot of traction, and a lot of people have shown interest to actually contribute back plugins for adopting for Amazon's container service and stuff like that. And there is a lot of community action around it. So hopefully in the near future, we can see more platforms being supported and extended.
Perfect. That's, it's an interesting conversation to have, because it may initially appear like it's a competitive thing where we're trying to get people off of our customers' platforms. But this has probably been one of the most requested services from the solution architects and other folks across Red Hat and at our end user organizations, because this really kind of reflects the hybrid nature of cloud, where people are lifting and shifting their workloads from one platform to another. And that this is all out in the open source too is pretty amazing. So I am, as I said, thrilled to see all of this work going on, and looking forward to helping you guys build out the community around it and seeing where it all takes off and goes to. So with that,
yeah, thanks, Diane. We appreciate it. Well, we look forward to all the pull requests that come in now.
Yeah, I have a few in my head. I think Tanzu to OpenShift, a few other things there. There's a couple of other things out there that could be fun, but I really think it's what the end user organizations have been asking of us. So this is not out of the blue, and really it's not about competing with other folks. It's about facilitating how organizations actually do their work and need to do their work. So I think you guys have done a great job here. And so thanks for the presentation today. I'll upload this to YouTube for everybody, and I'll get you guys to share your slides with me, and I'll link that into the YouTube description for anyone who's asking in the chat. And we'll get this up hopefully a little bit later today. Depends on how good the internets are for me. But we're rocking and rolling, and I look forward. I think we're going to have you guys back for the OpenShift Commons gathering on November 17th at KubeCon. I'm going to try and sneak in more of the demo on Move to Cube and any more highlights that we want to show off. So you can look forward to James and Ashok and maybe Amit as well, and a talk on that, and rocking and rolling to the next there. And I'm looking forward to December when we get the MTV out there, because I want my MTV. And I'm sure you've heard that joke before, and if not, you're not of a certain age. And I'm looking forward to December as well. So thanks everybody, and really, wherever you are, stay safe, keep healthy and happy, and we'll talk to you all soon. So thanks everybody for coming together today and making this happen.
Thanks, Diane. Thank you.
Thank you. Bye.
Recording